Okay, so in this video, we're going to try to draw arrays memory diagrams. So how do arrays get allocated in the computer's memory, right? So previously, we've seen, for example, if we want to, actually, let me start with this, right? So again, if we have int p, I don't know, 5, right? Now, when we see int p, we want to create a box, draw a box, label it P, put 5 in there, right? Okay, so now, and what do we say about turtles? Well, so far we've talked about turtles in the context of objects, right? So turtle, which is the class, let me actually label that with a different color. So here you have the class name. So this also counts as a type, right? So class name, a class is a kind of type. Now we have, let's just say Bob, okay, gets assigned to new turtle, okay. All right, so we have a few things. So here is the name of that object, or name of the instance, okay? Name of this turtle instance. So this Bob is an object variable. Okay, so Bob is an object or instance variable. I'm going to abbreviate that to var. Then we have this new keyword. Let me put red. So we have this new keyword. And then we have this interesting, oh, I think I already used that, turtle thing. Okay, so this together, so these lines together, gives you a new turtle object. And so how did we previously represent that? We basically said, okay, well, I see a type, right? I see a type, and I see the name of the object. Whoops. Name of that object, so, or the reference. So we create a box called Bob. And then somewhere out there, we have the actual turtle object, or the turtle instance. And it's got like XY coordinates, like you could also call forward on there. So it's a complete package of the whole turtle object. And now all it does is it has a reference to that actual object. Okay, so now let me erase that real quick. Now, when we look at how to create an array, we see something like this. So I'm just going to name this array for the purposes of I can't come up with any meaningful names right now. So we see new integer, right? And then we see maybe like 1, 2, 3. Okay. So based on what we've talked about so far, what do you think an array is? Like, how do we draw the memory diagram for an array? Like, is it do you think it's 1, 2, 3 in here? Or do you think it points to some other memory, part of the memory? And how do you know? Okay, so one thing you might say is, all right, well, integer, right, is not, it's a primitive, and it's not capitalized. And so I think, it's something similar to here, where I say, all right, well, I'm just going to write 1, 2, 3 instead of having it point here, right? Now, that's kind of the reasoning is reasonable, but what about the new, right? So the new keyword actually allocates objects. Um, so they actually allocate objects like this. So you kind of think of this part, this world over here is more like the complex memory. And over here is sort of like the simple memory. Okay? And so when you say new, you're basically creating an object in the more complex area, the more complex memory. And so an integer array, or any array, is actually an object. So it points over here to this complex memory where that holds 1, 2, and 3. Okay? You might say like, okay, but how does it hold 1, 2, 3 at once? So let me scroll down here a little bit. Whoop. Let me just actually move all that. Okay. So what it actually does, right, is let me sort of draw a line over here. And so let's first create an array memory box. And it's going to point to something. Okay. And it's actually going to point to an array of integers. So in this complex memory world, you literally have multiple memory boxes, and each of them holds a value. Okay, so it's kind of like the lockers, right? So remember we sort of talked about lockers, and when we did talk about lockers, it looks something like this. Now I'm just making making it harder to write for me. But let me zoom in on here a little bit, right? So here's our locker, and when we said, int x is set to like 5, we said, all right, well, we opened up a random locker, and we're just going to put 5 in there, okay? And then maybe another one comes around, and we say, all right, well, I'm going to put like Boolean y is true. Okay, and the computer is going to open up some memory, random memory, and it's just going to put true in there. And remember that all these lockers live over here. So you have the simple memory lockers, and now we have more complex memory lockers over here. Okay. All right, so now when we create an array, let me use a different color, green. Okay, so now when we create an array, integer array, whatever we wrote up there, actually I'm just going to complete it. So new int 1, 2, 3. Okay, when we do that, it's going to put that array over here, and it's going to point to some random part of the memory here. Now, what's interesting is that the array needs multiple lockers in a row. Okay, so the computer is going to open up 3 lockers in this example, and it's going to put each 1, 2, and 3 next to each other. So this is kind of like how that works. Okay, so now, how does the for each loop come in? Okay, so how does the for each loop come in? And actually, we'll talk about that in the next video.